All right. So the next thing we're going to jump to, because I really want to go through all of the steps involved in getting us to a functional script from a content perspective. So we are going to jump from here into Designer specifically. So the Designer tab, again, this little angle rule icon, is where we create the templates that we can assign content to. In the template editor, we're going to go and just create something from scratch so you can watch the entire process. Everything here are just the templates that have previously been created, and every template that has been created you can assign in a script. So once it's saved and present here, you'll notice that everything is either 1080 by 1920 or 1920 by 1080. Even if you're running a 4K presentation, the resolution is going to show 1920 by 1080. It's a weird thing in the way that Cisco Vision presents the space to you. And I'll show you, when we go to create a new template, we can't modify the width or the height. All we can do is select whether it's landscape or portrait. If you're running a 4K video region, a single 4K video region, the DMP will automatically just render that video in the appropriate resolution. So you can essentially ignore the resolution that it shows you in the template editor. The only thing that you need to be aware of is if you need to position a video somewhere apart from just in the full canvas, you'll need to do the math to figure out what the actual origin pixel would look like, because it won't do it for you in 4K. So we've created a new template.
So from what I'm understanding, if we upload a 4K video, it's going to compress it down to 1080?
No. No. If you upload a 4K video, it will play in 4K. It's just the template is going to show you that the resolution is 1920 by 1080.
So I'll lose 10%.
You won't lose anything. What I mean is the DMP is going to play it back in 4K. When it says 1920 by 1080, what it means is the full screen of the output of the DMP. It doesn't really mean 1920 by 1080, specifically in the template editor, right? It's confusing. It's a thing that I've been talking to Cisco about for a while, but just keep in mind, in the template editor, 1920 by 1080 just means full screen, right? So once you've created a new template, we'll go ahead and give this a name. You can zoom in and zoom out if you just wanted to have a clearer picture of the actual template. And then everything else is basically drag and drop. So we can start with a primary video region. Any video region is going to expect a mixed media playlist, going back to what we talked about before. Any non-video region expects a non-video playlist, and the two will not talk to each other. So the moment that I have a single video region and I wanted to populate a script activity based on this template, it's only going to show me a list of my mixed media playlists. Once I've dragged that region in, you'll actually see all of the parameters related to that region show up on the right-hand side. So we will start by setting the origin, the top left corner. That's really what tells us where the region starts. So the upper left-hand corner is at coordinate 0, 0. So if we change this x value to 0, you can see we've slid over to the left. If we change the y value to 0, we've slid up to the top. And that's how you position every item in a template. If you drag this region around, you'll notice that those x and y coordinates update automatically. And if I change the size of the region, the origin also updates automatically. But typically for our first video region, we usually want the origin to be at 0, 0, unless you want your region to be offset to the right, in which case just identify how far it needs to be offset and move it over. So this first template that we'll craft, we'll make 1920 by 1080. Now, again, I'm just going to reiterate, we say 1920 by 1080, but if you've uploaded a 4K video and it's only a full screen 4K resolution presentation, even though it says 1920 by 1080, it is playing back in 4K. Now you can name every layer. So if we say primary video, you'll notice that the layers below also update to reflect the layer name that we've set up here. You can create an alignment for the object. So if I wanted to say align left, it'll automatically move the origin to align to the left, and I can move it so that it aligns at the top. It's a good way for you to quickly identify the origin or to move it. And if we wanted to shrink this down and then put it in the top left corner or top right corner, right? We can go align top. Line right. And we've just moved it to the exact point that we want it to be. And then like we mentioned before, you'll see under type, type is set based on what you've dropped in. So video or mixed media. So for now, we're going to put this back at the origin, and we're going to make this 1920 by 1080. We're going to add some additional layers on top of this. So as you were mentioning before, you wanted to see how we did the overlay region. What we did was we dropped a non-video region on top of it, and we located this video region at the bottom right. And that now becomes our overlay. So we now have a 2-region template, and if you look at the layers, the layer order is the Z ordering of each of the individual regions that you've created. So if you were trying to do a picture-in-picture presentation, you always want to make sure that the small picture that's going to sit on top is at the top of the Z ordering, and that the one that you want behind in order sits behind it. So the top of the list is the front. That's going to be visible above everything else. The items at the bottom are at the furthest back. So in this case, the way that the overlay presentation works is this non-video region can take a PNG file with a transparency. So you produce a file that fits this size, that's transparent except for the place that you want the overlay to render. You build that as a playlist. You put that playlist in this region on an action. And we'll take a look at what's running in the script right now when we get into the script action piece. But the first part is building a template that has a region where you can put that playlist, and making sure that you populate that region with content that's the right size. If you were to put like 1920 by 1080 content in this playlist, it'll only show you the top left corner of the content. It won't scale it automatically. The only region that automatically scales is the primary video region. And so just for fun, we're going to add a secondary video region because I want you to see the Z layer ordering again. So we're going to call this hidden in the back. We're just going to put this behind all the other layers. So now that video is never going to be visible because it's rendering behind the overlay and behind the primary video region. If I want to bring it to the front, I can take it from hidden in the back, put it on top. Now it will render on top of the overlay and on top of the primary video region. Now, the only other note about secondary video regions is you will note there's this Enable Luma Key button, right? The Enable Luma Key basically says, do we want to treat regions that are configured for the right Luma range as transparent? That's what you would use if you're creating like an overlay animated L wrapper. Essentially, you take either the brightest or the darkest pixels in the file, and you say these will be treated like a transparency. Currently in Cisco Vision, there is no way to chroma key. It's Luma Key only, which is a bit of a challenge. Again, there is a feature request into Cisco Vision to convert that into a chroma key. It is possible on the BrightSign hardware, but not in Cisco's implementation.
So if you had an animated logo, you're trying to do the Luma Key, and it's a dark logo, or it has multiple colors in it, some are light, some are dark, is it going to have a problem with either the white or black, whatever you choose as the background, if there's colors very similar to it for the bigger logo? So
it's not about color, it's about luminance values. So from a broadcast perspective, right, you have typically like 2 sets of bits that are color values, and then you have a separate which is how bright or dark the pixels are. So with a Luma Key, what you're saying is you set how bright or how dark and what range, right? So you might start from 0, which is black, and you might say that from black to just a little bit brighter than black is treated as transparent. And all you have to do is make sure that when you're authoring content that nothing has that luminance value. In other words, you can enter into whatever your video production software is. This is the safe luminance values, and those will automatically present. Like typically, they'll render on your production software as cross-hatching lines, unsafe luminance. Same thing that would happen, like if you were doing video production, you might have something that's too bright and it's outside of range that shows the same thing. You can just bring down the acceptable brightness. And it typically is like the brightest color or the darkest color. You pick it on either side. And
Right.
it is a little bit less convenient to use than a chroma key, but it does also work for the purposes that you need it to. And typically, what you would do is you would make this 1920 by 1080. And you have two regions that are completely on top of each other. So we'll now call this LWRAP overlay and spell it correctly. We'll make sure that that's at the origin, and it's 1920 by 1080. And that's at the top of our Z-layer ordering. And in fact, what we can do is we can even take that third region and pop it to the top so that you have an LWRAPper, you've got a video region, an LWRAPper on top of the video region, and then like a static logo bug that sits on top of the LWRAPper. And that's what the template is that we've just created does. And this can be of any size and any position. But all that matters is making sure that your content matches the appropriate resolution for the region that you've created, and that it's in the right Z-layer ordering in your template so that it shows up at the right position. Any questions?
In the configuration under global DMP settings, default audio video closed caption, configuration property Luma key.
Yes.
Apparently we changed different colors. How does that?
So again, yes, and I'll actually open up the config tab and we'll look at what Alexandra's bringing up. So if we go into system configuration, global DMP settings, audio video. So this is a little bit misleading because it looks a lot like a hex value for a color. It isn't. It's actually 3 separate hex values that indicate the luminance value, and then the minimum, like the lower bound and the upper bound. There's a really good bright sign page that describes how that data is encoded and how you can create one of these values. The system default, I believe, is the brightest possible color as opposed to the darkest possible color. But yeah, it is something that you can customize. It's not, again, it's based on brightness and not on color. It's explicitly a luminance key and not a chroma key. But yes, it is customizable. And if you make an adjustment here, and we'll talk a little bit more about this when we get into the configuration page, but once you make a configuration page to global DMP settings, they don't take automatically. You do have to reboot all of the media players in your environment to get the configuration to change and take on your players. All right, so any questions about the template authoring process?
Can you add a template to a playlist that you've already created?
Playlists get added to templates, right? So like think of it like you've got a script with a state, you've got a group of DMPs, and then you take the template and you put the template on the group of DMPs, and then you put the playlist in the template. They come together in the script, but they're totally separate until you script them together. Do you have a specific, like, a use case that?
Yeah, because I made a script already, and I'd like to utilize this template.
Yeah.
I
So
have to build the template first,
yes.
then.
So you've already got your script, which means you've got a group or a zone of some DMPs. So so when you go to select the action for your group or your zone, you'll erase the existing action, and once you make the template, you'll see that in that list of actions, your new template will show up there. And so what you'll do is you'll select the new template that you've created, and then apply it to that group of DMPs. Then once you do, what you'll see, and we'll get into this when we start talking about scripting some more. Each of the regions of this template then show up in that center panel where you can pick your playlists, and you'll just pick a new playlist for each one of those regions. Okay. So the way that it works is the output. Remember how I was saying before, the 1920 by 1080 doesn't matter for the primary video region, because the primary video region is always going to want to scale its content up to whatever the full negotiated resolution between the DMP and the display device. So where this scenario is coming in for everybody else following along at home, the MU4 facility here at SoFi has basically two separate video wall controllers that take an input from two media players. The video wall controller negotiates a 4K template for this specific location. So the way that it works is a 4K template is really just 4 1080 templates, right? So whatever the size is, whatever the pixel dimensions are, if you divide them by 4, you get the equivalent if you scale it down to 1920 by 1080, right? So this size is saying, we've negotiated 4K, but I still have to do the math in 1080, right? And so we just divide all the pixel dimensions by 4, and that gets the canvas size that we need to use. And so we put it in the template right here. Does that make sense?
It does. I remember when I was on the phone with you when we were talking about it, you also mentioned that they had 2 ways to do this. Either this way, or adding a second DMP to just carry over the excess of the 1920.
Correct.
So you recommend this workflow as opposed to adding a second DMP?
And it totally depends on the controller, right? Because every LED controller functions a little bit differently. You see some where you have a 1920 canvas and it's a single 1920 canvas, but the pixels, the top right-hand region is actually the bottom set of pixels, and it pulls the top right-hand corner for the next set. It's a complete, a planar view is going to be totally different than a Samsung controller. Then, they each function a little bit differently. There's no good one-size-fits-all solution for building a template for a video wall, because there are as many video walls as there are arrangements of LED panels. You just kind of have to take each one as it is and then play with the template until you get the math right. But really the most important thing is, what is the resolution being negotiated between the DMP and the controller? And then what's the pixel mapping of the input to the controller versus the pixels on the physical board? And once you know those two things, then it's just doing the math and building the layouts.
So we can probably build an example or something to that.
I mean, that's the challenging part. Is there's so many different vendors for controllers, and the way that you can configure the controller versus the panels as they're actually physically deployed, it's not a standard like talking to a TV. The resolution really can vary, the mapping can vary. TD Garden is a particularly good example, right? They have a lot of LED walls that were built by different vendors. And those vendors all use different controllers that all map their pixels differently. So there's no way of building a single template that is a one-size-fits-all solution.
Just didn't know if there was a standard formula that we could chart out or graph out.
This is one where it really is it's a complete one-off. The closest thing we can think, even talking about your site signage, right? All of the site signage at SoFi it's the same per sign type, which is nice because you don't have to build out different templates for every individual location. But the signs all have different pixel mappings. So what it comes down to is, when you're authoring content, it's first you start from, if I provide a full 1920 by 1080 scaled presentation and I put it up on my LED wall, what do I see? Do I see the top left corner? Do I see the top right corner? Do I see something in the middle? Basically, you want to identify the origin where on the canvas the controller is actually taking and rendering that video. And then from there, make sure you count the actual physical number of pixels and then use that to create a region in the template that has the appropriate origin, and then author your content to actually hit that appropriate, resolution.
Yeah.
Yeah. So any other template related questions? Cool. We're going to spend a little bit of time on widgets. So really, there are a couple of ways of handling data in Cisco Vision. We're going to get into the configuration of GSYS and data sources and how that ties into what we do on these widgets. But just as a note, you can also handle a lot of this if you have third-party HTML rendering engines as well. So much in the same way that like your menu board system from CRI is HTML driven, and like we have a similar kind of like HTML engine that we use for menu boards and other stuff. You can also do HTML driven data sources that can be a little bit more visually functional than what you can do in Cisco Vision. But because it's really important that you at least know that this exists and how to configure it if it comes up, really, at the end of the day, once you have data sources that are mapped in Cisco Vision, and we'll talk about that when we dig in on the configuration tab side of things. Once those data sources exist, you can use the widget editor to basically drop those data sources onto a canvas. And that canvas can then also have video backgrounds or static backgrounds. And you can layer them the same way you would in a template. The only difference is that they also contain dynamic data-driven components. So we'll take a look at this demo widget. Oh, I'm just going to go back to one more thing. This applies both to widgets and to templates. At the top, just note there's an add button, remove button. The edit button lets you go in to make changes, but if you want to rename it, you actually have to hit this rename button. You can't rename it if you edit. So if I click edit here, you'll notice that that name field is not editable. So going into the demo widgets, we'll hit the edit field. So you have a few options. You have a text area, you have a graphic, you have text to screen, pic to screen, list, and data. A lot of these elements really overlap with each other. They serve very similar features. The text area can either be a dynamic text source or a static text source. You can see the way that I have this configured right now. I've dragged in a text area field. We'll note that much like with a video region or a static graphic region, we have an origin point and dimensions. So in this case, if I modify it, it'll change the same way. But I also have the option of rotating. So I can set this at an angle if I need to. And I can also set the size of the font. And additionally, I can import any fonts that I want to, and the system can use them to render text. By default, the only font loaded into Cisco Vision is Arial, which is why you'll note that the only option I've got right now is Arial. If the typefaces that you've imported have bold and italic, you can bold that text or italicize the text. You can also set the color for that font. This is, in fact, color. So you can just pick a standard hex color for the text that you want to apply. The next piece is data binding. So like I said, you have to have already set up your data sources in Cisco Vision. That configuration needs to be completed before you have access to it here. But you'll note that there is a source. So in this case, we'll pick demo, and then a field. We don't have any fields defined, so I'm just going to go and quickly define one so that we can do that. So GSYS clock, field mapping. We're just going to create and save. We'll leave that as clock time. All right. So now, our source will be demo, our field will be clock time, and now if this were a valid data source in your environment, where it says waiting for data, this would be replaced by the actual clock feed coming in your data source. The waiting for data field that you see here is the default data has not yet been received by the system. There are a couple of other steps involved for actually setting the data fields up, and something that you have to do before it'll actually become active in the system. We'll talk about that too. We don't have anything active right now in the SoFi environment to show you a live example, but this is how that would be configured. And then much like any other presentation, you can order from a Z ordering perspective. Let's put a graphic in here. We'll call this 1920 by 1080 at the origin. And then we can choose our source here and just pick a background. So now we've chosen as our just whatever the piece of static background content we want to be. We'll put the text in front of it so that it renders. And functionally, that's really most of what goes into developing widgets for data. You can also use data binding on a graphic. So like, for example, you could point to a piece of external content by saying, like, you have an XML file hosted on a web server somewhere, and then in the XML is a file path for a graphic, so that that graphic would then just get pulled off of the network. You can also do a thing where you can create lookups. In other words, in the data field, you can have the name of a file that exists in Cisco Vision, and then as that file changes in the data source, it changes to another file that's referenced in the Cisco Vision content library and modifies the graphic for that as well. One of the big notes, there really isn't any way to do any kind of animation of any of these graphic sources. You can't make them scroll, you can't make them fade. All they can do is they can receive the data that is coming in on the data bound socket and cycle between a list of items. And that's really about all that you can do with it. But it can still be a cool feature. Text to screen, you'll note that this is pretty much the same thing. This is about, let's say if you had like a social media integration, you could have two different items. One pops up and then fades into a second item. So you'll note that there is a text effect here, which is fade. And then the data binding is expecting that you will have two different data sources that will populate in the list. I don't find this to be typically a very useful like text piece in the widget. There aren't a lot of situations where this applies, but just as a note, it's there. And what it's really doing is it's going to identify a list of two items in a data structure and say, we'll play the first one, and then we'll fade to the second one. And during the 5 seconds of fade, the expectation is the first item will change to something new, so that after another 5 seconds, it'll pop back to the first item in the list. And then it'll repeat that process, continuously overwriting two pieces of data. And then list is pretty much what you would expect it to. You're creating a table of individual items. So let's say you were trying to build something like a menu board this way. Maybe you would have something like appetizers. And you'd say, we have 5 appetizers at the stand. You'd create 5 cells. Those 5 cells have a particular pad. They're in a grid format. They have a particular width. And then the same thing. You'd select a data source and a field. And the expectation would be that that field has 5 items, and it would populate each one of these grid locations as a separate item. So this can get kind of involved. It really has a lot more to do with what data sources you have available and what your concept is for visualizing them. So if there's a specific case that applies at either of your venues where you really think that there's a use case for data and you want to use these widgets, this is something that we could do some additional diving into on a case-by-case basis to assist with.